So today, lesson 9.2, solving quadratics. This is the last possible method. It's called the quadratic formula, and here's the coolest thing about it, man. It works every time. Every single quadratic equation can be done. It doesn't matter if it's just only got x squared, if it's only got x's, right? It doesn't matter about the a value being 1 or not. You know, it doesn't matter about b being even or anything like that. It works every single time. Works every time, baby. Any single quadratic will work for it in standard form. Here's the rule, though. It's got to be what I call ready to run. It's got to be equal to 0 first, right? You got to have it equal to 0. And all you need to know is what a, b, and c are. So here it is. This is the quadratic formula, which is a mess. And I hope you guys trust me that here is the hardest part about today's lesson. If you do not know the quadratic formula, it is very hard to use the quadratic formula. Are you with me on that? So here's what we're going to do. We are going to say this a couple times, and then if you're watching in video land, you will not partake in our little experiment here today, but we're going to do another little experiment in class, and then you will just have to tell me, if you're watching this on video, it's like, hey, can I practice the quadratic formula like you did in class? So here's what we'll do. I'll say it a couple times first because it's weird, right? And then we'll say it together. So we'll forget about the x equals part. This is just solving for x. We're going to start kind of right here, right? So this says, I think we're pretty practiced with it. It's not really negative b. Are we down with the fact that that's the opposite of b, right? So the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. Whew! What a mess. Too much to say at once, so we're going to say it in phases. Ready? Repeat after me. What I say, you say. Opposite of b. Plus or minus. Square root of b squared minus 4ac all over 2 times a. One more time. Opposite of b. Plus or minus square root of b squared minus 4ac all over 2 times a. And now it's experiment time in class. So we actually wrote that and said that many, many times, and we're going to do the same thing now as we do our worksheet. So first question first is they say solve with the quadratic formula. Okay, we're going to do that. I have a bonus step. I even program it into our homework. Is first we have to see if this quadratic equation is ready to run. I mean, is it equal to 0 first? Yes. Then we will do this. We will identify a, b, and c. Because, my friends, if we get a, b, and c wrong, the whole thing's not going to work. Because we just got to substitute the numbers into the formula. So how much is a? Not x squared. It's got to be a number. What is it? 1. How much is b? -3, and c is 2. Trust in this process. I have been doing this for 30-some years in my head when I do the quadratic formula. I'm going to say the quadratic formula in my head, but write numbers down. So I have to do it out loud so you know what I'm talking about, but this is what your brain should be doing in the inner monologue. I'm going to do the opposite of b. Would you believe I'm not going to write opposite of b down? I'm going to write +3 down. Cool? You have to show all this work, by the way. So I did opposite of b, plus or minus, square root of, and then here's a move I would like us to do, hopefully without a calculator. You know, depends on how big b is. But isn't the next thing b squared? Because I think the people who use the calculator will make more mistakes with this. Everyone in here, if I ask you out loud, knows what -3 squared is. What is it? It is a +9. Are you with me on that? But many people run to the calculator to punch in -3. I'm sorry I didn't have it open. And your calculator will not give you the correct answer if you punch it in wrong. -3 squared should be +9. Are you with me on that? Why didn't it work? Because I didn't put the negative number in parentheses in that case. Use your brain. Your brain is better than a calculator. Every one of you knows a negative number squared should be positive. Does that sound okay? So instead of doing b squared or writing -3 squared, we're just going to go straight to 9. I put them in a different color just because that is something we computed ahead of time, right? We computed that. So I did opposite of b plus or minus square root of b squared. Then I'm going to do minus 4. And then notice I'm going to put all the multiplying in parentheses because that's how to type it in the calculator correctly, times a times c, right? So instead of using multiply dots or multiply x's, I use parentheses. So I have opposite of b plus or minus square root of b squared minus 4ac all over, and then there's one more bit of calculation we can do, 2 times a, right? How much is a in this case? 1. What is 2 times 1, baby? 2. I do not expect us to be very good at this until about the 6th or 7th problem. Does that kind of make sense? So it's just kind of hang with me, right? So how do you feel about why I put the numbers in the places that I put them? Because that's what the formula says. Cool? Then I'm going to do this. So work shown, that's phase 1. Phase 2 is to figure all this crap underneath the radical out. Do not use the square root button, but just grab your calculator, please, and let's just punch what we see, but no square root sign around it. You see it says 9 minus 4 times 1 times 2, and notice I use parentheses for all that, right? You see how you guys need to punch this in also so you make sure you can punch things correctly, okay? So do you see I just figured all that stuff underneath the radical out? What did you get? 1. Ooh, I love 1. Just like 4, 9, 16, 25. What's so great about 1? It's a perfect square. So here's what we have done now. 3 plus or minus the square root of. We figured out the red number. In a couple problems, I'll explain to you what the red number is called, but this is just too new to kind of tell you everything on the first day. Are you cool that I have found the number underneath the radical? He is a perfect square, so we can go further on this guy. What is the square root of 1, my friends? 1. So now I will simplify this to become 3 plus or minus 1 over 2. How do you feel about this orange blob cleaned up to actually be the number 1, right? The square root of 1 is 1. How many answers are there? 2 of them, right? There's totally 2 of them. So I'm going to do this. I'm going to do 3 plus 1. What is 3 plus 1, baby? So we have to figure that out first. Then we have it over 2. Or what is 3 minus 1? 2. It's over 2. Do you see all I did was separate the plus or minus? I did 3 plus 1 and I got me a 4. I got 3 minus 1 and I got me a 2, but it was still all over 2. Can those fractions clean up at all? What is this? 2 or 1. Man, that worked. I got to the right answers. Did they come out nice? I could have factored that. Would you believe this is easy factor? And all I had to do was find 2 numbers that multiplied together to be 2 and add together to be -3. And they are -1 and -2. Are you with me on that? Like if you know how to get from Hayes High to Walmart a quicker way, you would probably take that way. Do you know what I'm trying to say? But this works as well. That kind of sucked though because I could have factored that. If I had to choose once I get experience, I would have chose a different path to take. But let's try that again. Today we are practicing the quadratic formula. First, it has to be ready to run. Means equal to 0 first. So let's get him equal to 0 first. I'm going to subtract that 21 over to the other side. And you know what I'm going to do? I'm going to talk myself through factoring this just for one. Just look at it. Would you want to factor this? Like you'd have to see if there's a GCF. Between a 4, a 19, and a 21, do you think there's a GCF? Nope. So all that other crap's going to fail. You would have to frowny face factor this, right? And aren't the numbers really, really big? Do you have any interest in finding 2 numbers that multiply together to be 84 and add together to be 19? I have no interest in that. That's going to take too long. The quadratic formula would be faster than this, than that, right? So let's identify A, B, and C. Who is A? -4. Who is B? 19. And C, hey, is he 21 or is he -21? Do you see how you had to get him equal to 0 first, right, to get your C value? So he's -21. Okay, I'll say this stuff. This is what your inner monologue should be doing, but you're going to write the numbers instead. Opposite of B. Did you put -19? Right? Plus or minus square root of. B squared, probably got to run to the calculator and figure that out, right? It's 19 squared. Should it be positive or negative? Always positive. 19 squared is 361, is that right? Okay, so now I'll keep going. Minus 4 times A, so use parentheses, times C. And make sure all of that stuff is underneath that square root symbol. And then here, I want to go all over 2 times A. What would 2 times A be, my friends? Negative 8. Cool. I'm going to start using the big word because of what the entire backside of this worksheet is. Next thing we're going to do is find, sorry, that's not a highlighter, find this thing, the number underneath the radical. That's called the discriminant. It's a weird word, right? Find the discriminant. So all you got to do is punch all that stuff in your calculator. Do not use the square root symbol, though. Just do 361 minus 4 times negative 4 times negative 21. And you see, with all these negatives, using the parentheses is going to be awesome because we won't have to worry about making sign errors and stuff. So cool. What did you get back? 25. Ooh, I love that number. What's so great about that number right there? It's a perfect square. What that means is we could have factored this guy. If the discriminant comes out to be a perfect square, you could have chose factoring. It would have been a mess, though, because the numbers are too big to deal with, right? I don't want to spend all that time finding those two numbers. So let's clean her up. Negative 19 plus or minus. What is this guy right here? What is the square root of 25? Yes, you said it correctly. I'm going to write it incorrectly. What did I write incorrectly? It is supposed to be 5. What did I accidentally write down? Square root of 5. So nope, nope, nope. It's just 5. Square root of 25 is 5. All over negative 8. So now we got to find our two answers. So if we need to use a calculator, no problem, but we're only going to figure out the numerator first. I would like to explain this. We're going to follow the order of operations. What's the first move in order of operations? Like, please excuse my dear Aunt Sally. Yeah, most people say parentheses, but we, I don't know if you remember, did GEMDAS instead of PEMDAS. G stands for grouping symbols. Do you know that there is a grouping symbol in this guy? The grouping symbol is the fraction bar. As in a fraction, two groups, numerator and denominator. We got to clean up the numerator first. So what's negative 19 plus 5? If you need to use a calculator, great. Negative 19 plus 5 is negative 14 over negative 8. We'll clean that up later. I know it will reduce. We'll clean it up later. Or do negative 19 minus 5, negative 24, right, over negative 8. Now we can clean up both of those little fractions right there. So negative over negative is positive, right? What's 14 over 8, baby? 2 goes into each one of those. 14 over 8. 7 over 4, or 24 divided by 8, 3. Did those answers come out nice? Yes, they did. What do I mean by that? There's no square root signs with them at all. Those are rational numbers. You could have factored that. Factoring would have been a bad choice. Let's try again. If we go to number 3, is he ready to run for the quadratic formula? Nope. Get him ready to run. 2x squared plus 6x minus 5 equals 0. Then identify A, B, and C. A, B, and C. Check your A, B, and C's with mine. And this will be the last one I'm going to talk you through. The rest of them, you have to talk yourself through it. How do you talk yourself through it? Say the formula one thing at a time, but write the numbers that go in that spot. So here you go. I'll say it. You write it. Opposite of B. Plus or minus. Square root of. B squared. Stop and look that you have the right number. Minus 4 times A times C. All over 2 times A. Please look up and see you have the right thing. It's very easy to make a mistake. I make them too, right? So we have the right thing. Find the discriminant. That is the number underneath the radical. Find the discriminant. And then we'll rewrite it like so. Just got to put that discriminant in there. And what did we get this time? 76. Ooh, here we go. Is that a perfect square? Nope. Means we could not have factored this, right? If we would, we'd have to frowny face factor. It would be multiply those together, get negative 10. Find two numbers that multiply together to be negative 10 and add together to be 6. Couldn't do it. Would you complete the square on it? Nope. A is not 1. Are you with me on that? A is not 1. I could divide everything by 2. That would give me negative 5 halves right there. I don't want to deal with a fraction. Quadratic formula is the best way to do this problem. So, what did we say? It was 76. Is that what it was? Cool. Let's do this one time and one time only. The square root of 76 can simplify. Find the biggest perfect square that goes into 76 evenly. What did we find for the biggest perfect square that goes into 76 evenly? 4 goes in there how many times? 19 times. So do you see how I have split that guy up? And then this dude right here can clean up. What is the square root of 4, my friends? 2. So here's what we got. And the reason why I wanted to show you this is because that's supposed to be a 19 right there, is it shows the triangle of death. There are ways to see if this can still simplify. If I could use a pen, sorry about that. Didn't we have this? This is the triangle of death. You are looking at those 3 numbers right there. Is there a common factor between those 3 numbers? So what could you factor out? 2. Let's reduce all of them by 2. The radical doesn't matter. He's going to stay there. So what is negative 6 reduced by a factor of 2? Negative 3, plus or minus. What is 2 reduced by a factor of 2? 1, which I don't need to write down, but there is a square root of 19 with him. All over, not 4 this time because I want to reduce it by a factor of 2. That would be 2. If you had this, my friends, though, if you had an answer like that, this doesn't reduce. Are you with me? That the triangle of death, even though the 6 over 2 reduces, there is a 7 in a part of this. You have to be a common factor to all 3 things in the triangle of death. So how do you feel about that guy right there? I hope you could say thumbs down to that, because there is no need to simplify these radicals on today's homework or what we are going to do for this chapter. We would have left it like this. So we're going to do that on every problem going forward. I just wanted to show you that it is possible to get a better exact answer than what we had. Right? So, all right, from here on out, we will not simplify any radicals, and we will change them to decimals on some of these answers also. Cool? So, all right, let's go. Hey, would you even dream of trying to factor that if the A value is 48? Numbers way too big. Are you with me on that? The numbers are too big, just like on the skill check today, the choice. Hey, A, B, and C are too big. Even if it could factor, I would rather, this is faster. Are you with me? It's just put the numbers in the formula and get it. So, is he ready to run? Yep, set him up. Set him up. And if this is your first rodeo, baby, say the quadratic formula to yourself while you write the numbers down. So I paused for a little bit so they could do the opposite of b, plus or minus the square root of b squared. You go ahead and punch 22 squared in your calculator and get 484, minus 4 times a times c, all over 2 times a. What is 2 times a, my friends? 96. Did you get the numbers in the right place? Find the discriminants. Find the discriminants. That's this number underneath here. So negative 22 plus or minus the square root of something over 96. So we'll punch in 484 minus 4 times 48 times negative 15, right? Did we get a big boy, right? Would you believe I do not want to even dream of trying to simplify that radical, because a lot of times they're going to come out so big. Why are we using the quadratic formula? Because the numbers are going to be big, right? So, but here's what I do want to check. Is 3,364 a perfect square? Punch that in your calculator, like square root it. Is that even a perfect square? What do you think? Yes, it is. That means we could have factored this. We could have frowny face factored it, but you would have had to find two numbers that multiply together to be whatever this is, negative 720, and add together to be 22. It would take you too long to find those two numbers. Do you know what I'm saying? This is the faster way to do it. So it was 58 is what that turned out to be when we square rooted it, so we're going to put 58 in that spot. Now see if you can find your two answers. Break them up into two fractions. The first one I always like to do plus. The second one I like to do minus, just so my brain knows which one I have done, right? Like I do negative 22 plus 58, so you figure that out. And then just put 36 right there over 96. We'll clean them up here in a little bit. And do negative 22 minus 58. Negative 80 over 96. Cool. I also have no interest in really trying to reduce these fractions with my brain because it's just too big of numbers, right? So it's not like it's hard, but here's what you do. If you have your little blue calculators, they probably just reduce them and you know how to do it already. If you have one of my graphing calculators, sorry, I hit the wrong button, you do this. First one is 36 over 96, so hit 36 divided by 96 and hit equals. It will give you a decimal back. I don't want that decimal when the answers came out nice. These answers did come out nice. But if you hit this key sequence, it's called math, enter, enter. If you see there is a button, it's the third one down here that says math. All right, so hit math. And then if you hit enter, it says, hey, do you want to change this to a fraction? And then do it one more time. So we call it math, enter, enter. Right? It will change that into a fraction. So this was 3/8. Do the same thing for this guy. Type negative 80 divided by 96, have them as a decimal, and then hit math, enter, enter. If you have your own calculator, you know how to do it, awesome, right? But on the graphing calculators, this is how you do it. Math, enter, enter. Did you get negative 5/6? Although we don't like fractions, when I ask the question, does it come out nice? The answer to that is yes. That actually came out nice because there was no radicals with it. Cool, let's keep going. Set them up for the quadratic formula. So we're checking to see if we got our numbers in the right spot. And then here's what I just told them. I'm going to take off points if you do that. That's wrong. Do you see how the square root symbol does not cover everything underneath the discriminant in that case? Please make it long enough to cover it. Because all that looks like right there is square root of 25. You know what I'm saying? So like make sure that your square root thing goes all the way. Sound cool? So, all right, let's find the discriminant. And punch in all that stuff in. 25 minus 4 times 2 times negative 8. I trust that you can punch it in. See if you get the same number I got. I got 89. Did you get 89? Is 89 a perfect square? No, it is not. So I don't care about simplifying the radicals anymore, but homework is going to ask sometimes to give like fractional answers. That's kind of like a clue that the discriminant is going to turn out to be a perfect square because we got fractions for answers. And sometimes they're going to say, please give your answer as a decimal, right? So here's what we'll do. There are two answers there, correct? We have to do the entire numerator first. So grab the calculator and punch with me. The numerator, the first time, is going to say negative 5 plus the square root of 89. But you cannot put divide by 4 after that. That's going to come later. Just do the numerator and hit equals. Are you with me on that? Did you get this number back? What do you need to do to that number? What do we need to do to that number? This is not the final answer. This is the numerator. That's not a highlighter. What has to happen to it? What does the bottom say? divide by 4. Are you with me on that? But let me show you this then, since you guys have put, so we'll do this, right? Are you okay with that? Look at the difference. Negative 5 plus the square root of 89 divided by 4. Why did I get a different number this time? Because I didn't divide the entire numerator by 4, right? You have to figure the numerator out first. Or if you want to put the numerator in parentheses, you can do that. And I'm not mad about this. I'm just kind of like realizing, oh yeah, we're very inexperienced with stuff. So you could have done this and then hit divided by 4, and that would get you the right answer. But to me, it's easier to just punch negative 5 plus the square root of 89, hit equals, right? I just figured out the numerator, and then hit divided by 4. So we're going to this. We're going to put about 1.1. Rounded that to 1 decimal place. That was one answer. I used the plus in the plus or minus. What do I still have to use? The minus. So let's start over. Let's do negative 5 minus the square root of 89 and hit equals, baby. What do you have to do to that after you have hit equals? Divide by 4. Or whatever that denominator is. In this case, it's 4. Did you get negative 3.6 if we round that to 1 decimal place? So there's 2 answers there. Do you know what this symbol means? I'm not sure if you do or not. I put that symbol in front. Do you know what that means? Approximately, because didn't I round these guys off, right? So you only have to put it once because I know there's 2 answers. You rounded both of them. Nice? 2 left, right? Let's see if we can set number 6 up correctly. Solve with the quadratic formula. And then see if your setup, you got the numbers in the right place. Did you get the numbers in the right place? And if so, find the discriminants. Negative 9 plus or minus the square root of, got to punch all that in, so 81 minus 4 times 8 times negative 4. I'm going to save you guys time in video land. Check to see if you get the same number I got. I got 209. Is 209 a perfect square? If you're not sure, you can square root it and see if it comes out nice. If it comes out nice, we'll keep going. If it doesn't come out nice, we'll leave it the square root of 209. Is 209 a perfect square? Nope. So let's get decimal answers. We'll punch this in. First, negative 9 plus the square root of 209. Hit equals. Negative 9 plus the square root of 209 and hit equals. And last time I divided it by 4. This time I'm not going to divide it by 4. What am I going to divide it by? 16, right? So divide by 16. And I got about 0.3 if I was to round that to 1 decimal place. So approximately 0.3. Find the other answer. He should be the minus. So negative 9 minus the square root of 209. Hit equals, and then divide by the denominator, which is in this case 16. So I got about negative 1.5. That's rounding to the nearest tenth. I believe that's what homework wants. If they want hundredth, that's 2 decimal places, right? So just round what they tell you. There is one more that I would like you and a neighbor to do together, right? Get him set up a little bit. We have discussed that in this green dot could be a problem, especially if you are just a calculator person. And this is really big because our brains know what negative 4 squared is. It is a positive 16. But that said, like negative 23 squared, it's amazing how many people would punch negative 23 squared and their calculator would give them a negative without, because they didn't use parentheses. Just do the positive version of that guy squared, right? So it is a 16. So did you get those 2 answers? This discriminant was 784. Is that right? 784. That is a perfect square, by the way. 784 is a perfect square. But you know what? a lot of people forget to check for that. If they still started punching this in, 4 plus the square root of 784, I'll bet you got 32 when you did it, right? You know, didn't you kind of punch all that stuff in, right? Over 16, or negative 24 over 16. I might have went a little fast for us here also. Sorry that I kind of let the cat out of the bag. But I got some questions for you. What if I gave you a choice of how to do this? First question, is it factorable? We already know the answer. We're just a little too new to know. Was the discriminant a perfect square? Yes or no? So was it factorable? Yes, it was. So let's go back and see what happens. First thing some people notice is they're like, hey, Ms. Fonestiel, 8, 4, 24, 8, 4, 24, 8, 4, 24. We're like the numbers. I know some of them were negative. 8, 4, 24. What could you have done? You could take a GCF out if you wanted to, right, and still do the quadratic formula on it. Do you see how I divided everybody by 4, right, in that case? So I could do the quadratic formula on that dude right there. Should I get the same answers? Yes or no? I would hope so. Shouldn't the answers be the same regardless of which way? So if I did it, do you see what happened was I made the numbers smaller. So I did the quadratic formula with those 3 numbers, an a value of 2, a b value of -1, and a c value of -6. And when I did that, I got a discriminant of 49, which everybody's brain in here knows that's a perfect square, so they kind of like clean that up. But it's still factorable. I could have chose to factor it if I wanted to. What kind of factoring would you have had to have done? Easy or frowny face? What do you think? You see we're still a little unsure, which is totally normal, right? When can you easy factor? A value has to be how much? 1. When do you have to frowny face factor? When the a value is not 1. So what would you have chosen, easy or frowny face? Cool, I did that, right? Here I could take out the GCF, of course, and I want to frowny face that guy. So I went through all of that rigmarole, and did I get the same answers back in that case? Sure did. There's many ways to get from the Hayes High parking lot to Walmart. Which one is the best? It kind of depends on the situation. There's nothing wrong with doing it the first way. It is what I highly recommend because were the numbers large in this case. 8's not that big of a number. 4's not that big of a number. 24's but if you have to frowny face it, right, you multiply those together, you're going to start getting some really big numbers. Cool. It seems like we still have a long way to go. The backside will be very, very fast once I explain a couple more things, right, because we have talked about it already. Do we know where the discriminant is in this quadratic formula? Where is the discriminant? Tell your neighbor. It's that number that's underneath the square root or underneath the radical, right? But let me just kind of go through some stuff we didn't talk about. Let's say I had 3 different guys right here. I'm just going to make them all the same. -5 plus or minus square root of this over 2, and then like -5 plus or minus the square root of that all over 2, right? I'm going to give you 3 different situations. Here, I'm going to make the discriminant be that. Does that sound all right? Here, I'm going to make the discriminant be that, right? And here, I'm going to make the discriminant be that. Does that sound all right? Tell me about this. What do you think? Do you like that or do you not like that? I love that. That's a perfect square. How many answers will you get? What is the square root of 25, guys? 5 or what? -5. We're kind of new at that, but that's what the plus or minus is all about. But what if I chose something else? What if I chose an 8? Punch in the square root of 8 in your calculator. 8 is not a perfect square. Are you with me on that? But does it actually come out to a number? I know it's nasty, right, Definitely. Did you get a number back? Yes or no? You would get plus or minus that nasty decimal in that case, right? And for those who have their calculators in the wrong mode that's giving you 2 square roots of 2, we need to change that mode back to something that will be giving us decimals. Does that kind of make sense? Remind me to do that after we're done here today. But we don't want our calculator in simplify radical mode for quadratic formula. But here's my point. How many answers did you get? Did it come out nice? I should have said that differently. You are correct to answer that. When I said did it come out nice, the answer was no. Did you get answers? Yes or no? And there will be 2 of them, right? So this has 2 answers. You don't need to write this down. What about if the discriminant is 0? Could you please punch in the square root of 0 and see if that even works? Can you think of two numbers exactly the same that multiply together to be 0? 0 and 0. So the weird question is 0 a perfect square? It actually is, right? But there's no plus or minus 0. Are you with me on that? Like, you can't have plus 0, you can't have minus 0. So would you believe this would have one answer? And then the last one, please punch in the square root of -7. Does your calculator give you an answer, or does it give you some sort of error message? You know, some of us will have like totally different answers, you know, like what the calculator says, but it should all say, nope, not happening. Because I'll even do square root of -25. People are like, well, what about that? What if you did the square root of a negative perfect square? Not going to happen, right? Because what are two numbers exactly the same that multiply together to be -25? It sure is not 5 and 5, because that's positive 25. And it's not 5 and -5, because those aren't the same two numbers. Aren't those two different numbers? You cannot take the square root of a negative number, can you notice what my calculator says? In real mode. As I've been saying all year long, algebra will get crazier. We will start to do this over again your junior year with imaginary answers. But that's for 2 years down the road, right? We're keeping it in the real number system. And imaginary answers are way easier than you think. Don't let it be scared. But there's more to this than just this little bitty thing that we're doing. So this one here has no real solutions. That is all about the discriminant. If the discriminant is positive, you will get 2 answers back. If the discriminant is 0, you will get 1 answer back. If the discriminant is negative, you will get no real answers back. So that's what the backside is all about. And I kind of have an extra bit here. I know this is not on your paper, but there's homework questions like this. You have to read a graph and tell me what the discriminant is. What we learned last chapter was, didn't all quadratics make a parabola? Can you kind of see those in red, right? And what we found was the x-intercepts. Everything we did today by using the quadratic formula by solving for x is because we let y equal 0, and those are the x-intercepts. Talk to me, Goose. Here's the x-axis. It's kind of tough to see on my small little guy. How many times does that parabola cross the x-axis? Once, twice, or never? 2 times. Those are how many answers it has. It has 2 answers. And since you got 2 answers back, that discriminant would be positive. It's not even on your worksheet. I'm just showing you some because I didn't put them on the worksheet because I ran out of space, right? So if it crosses the x-axis twice, you have 2 answers, positive discriminant. How about this? How many times does that does that parabola touch the x-axis? Once, twice, or never? Once. That means that the discriminant is 0 because you only get 1 answer back. If you do this, if you take the square root of 0, the plus or minus becomes null and void. There is no plus 0 and minus 0. It's the same thing. 5 plus 0 is 5. 5 minus 0 is 5. You get the same answer back both times. But over here, how many times does this parabola touch the x-axis? Once, twice, or never? Never. That means that the discriminant was a negative number because you get no real solutions to that. The solutions are the x-intercepts. So let's get better at that. Without graphs, it's all about the discriminant. You told me, isn't the discriminant the formula underneath like the radical? Isn't it just the b squared minus 4ac part right here? So here's what we're going to do. Is this guy ready to run? Yes or no? Let's find A, B, and C. A, B, and C. A is 3, B is 2, and C is -3. And notice they are not asking me to find any answers. They want to know, like when it says solutions, I should have typed it as number of solutions, so my fault. They want me to find the discriminant. I don't need to do the entire quadratic formula. I need to do this, b squared minus 4ac. Notice the square root is not around it, right? So let's sub that stuff in. B squared is 4 minus 4 times 3 times -3. Find the discriminant. 4 minus 4 times 3 times negative 3. And how much did we get? 40. Are you guys okay with 40? What kind of number is 40? Positive number, negative number, or 0? Yeah, it doesn't matter if it's a square root, perfect square or not, isn't it positive? If you take the square root of 40, will your calculator calculate it? Yes, it will. How many answers do you get? 2, because isn't it the plus or the minus in that case? So how many solutions does this guy have? 2, because the discriminant was positive in that case. They would be 2 nasty answers, by the way, because 40 is not a perfect square, right? They would come out decimally. Next guy, let's find the discriminant. I don't care on this if you don't do the a, b, and c. That's up to you. But don't we have to do b squared minus 4ac? Who is b? Negative 7. It needs to be squared, so that would be 49 minus 4 times 3 times negative 8, right? We'll punch that in. And I got 145. Please check that I punched. Sometimes I make typos. Did you guys get 145 back? And here's what your brain has to do. Is that positive, negative, or 0? Positive. If you punched it in your calculator to square root it, right, because the discriminant is the thing that gets square rooted, would you get 1 answer, 2 answers, or no answers back? You would get 2 because of the plus or minus thing. These parabolas, if we graph them, would cross the x-axis twice, right? The x-intercepts are the solutions to this guy. So let's do that again. Let's do b squared minus 4ac. That is the formula for the discriminant. Make sure you got the right numbers in the right spots. And then we punch that in. Hundo minus 4 times 6 times 10. I got negative 140. Did you get negative 140? This is the number that needs to get square rooted in the quadratic formula. If you square root a negative, will your calculator give you an answer back? No. So you will have like no x-intercepts on that, right? There's no real solutions, right? So that's what we are going to put. No real solutions. Not trying to scare the crap out of you. There are solutions to this. They are imaginary. That's for 2 years. That's why we just can't put no solutions. We put no real solutions. And we'll do one more of these, right? Find the discriminant. Find the discriminant. Find the discriminant. So b squared minus 4ac finding the discriminant. What you got for a discriminant? 0. That is the number underneath the radical. This is such a mental optical illusion type of thing, because the discriminant is 0. Can you take the square root of 0? Yes. How many answers will you get back? 1 solution, right? It's so weird because 0 mentally makes you want to say that there's no solutions to it. It's like, no, there is 1 solution to it. Okay? I think that is enough, right? So we will definitely have to do some work on paper. Let's see what we got, man.